Hello, Daisy engineers. My name's Lori, and today we are going to do the Daisy Mechanical Engineering Badge number 3, which is Model Car Design. Today, you're going to build and test your own model car, just like engineers do. When you've learned this badge, you'll know how to design, build, and test your own model car. And more importantly, how forces that engineers have to know about, like friction and applied force, change a car's speed. So here's a list of the supplies you'll need. We'll talk about these again later. You can reference this back, but I just wanted to let you know some of the things that you want to keep in mind and try to collect from your home if possible. I wasn't able to get to the store to do my car, so I just had to make do with what I could find because Girl Scouts are resourceful. So cars are engineered to move us, right? There are many kinds of machines, types of machines to get us places we want to go. They use different ways to move. They get energy. Skateboards get energy using wheels and our muscle power, leg power. Bikes use wheels, gears, and muscle power. Boats, planes, trains, and cars use engines and fuel like gas, diesel, biofuels, or electric batteries. Other things that affect all of these and how they move across a surface are called forces of motion. Two of these forces are friction and applied force. Force on an object and the force friction between two surfaces. So when two surfaces rub together, like cars on a road, car tires on a road, they rub against each other and it causes what we call friction. So friction is a force that grabs or pulls back on moving objects to slow them down. So if you think about rough gravel roads, they create more friction on a car than a smooth road. We'll give a good example of that. So the pull or the grab is lower for cars on icy roads. So with less friction, if you had a car on an icy road, it'd slip all over the place, right? There's less friction, less grab of the road and the car as they slide over each other. Literally, the car would slide on an icy road. But we do something by adding, we increase the friction of the car, tire, and the road by using snow tires and chains. So by putting those on our car tires, it grips the road better. We have better friction, and friction, it grabs the road better on an icy road. So that's a great example of very low friction. Now, applied force is simply a force of pressing down on something, but as it relates to friction, if you press down on your car or your car weighs more, or if you add weights to it, for instance, if the car has one person in it, but then you add 4 more people, it will have weight and that will affect the friction. The friction will go up and you might not even notice it, but pull against the car moving forward just a little bit. So it will slow it down a bit. The more applied force, the more pressure you have or weight on your car, the more friction there will be between the car and the road. So let's do a friction experiment. I want you to rub your palms together, dry palms, really, really hard as you can. Start to feel something? like it warms up a little bit. Friction also causes heat. We're not going to address that today, but you can feel it when you're rubbing your hands, right? And your hands are dry. And they've got some bumps and you've got your fingers and all the bones and stuff. So it's a little bit of a rough surface. Now rub your palms. Go over to the sink and get some soap and water. Rub your palms. What happens? And try and rub hard. What happens? They slip, kind of slip past each other. Can you generate any heat that way? Not really. You could rub and rub and rub and rub and probably never get warm. Not as warm as when you rub your dry palms together. So, did you find that it was easier to rub your hands together, or there was less pressure when they were in soapy water? So what do you think? Is friction more or less when your hands are dry? You know that answer. I don't have to tell you. So how much friction there is between two surfaces rubbing together depends on the texture, how rough a surface is, how rough the road is the car is riding on, and pressure and force. The force of applied force. That is how strongly those two surfaces will press together. So here's an illustration, a picture. Friction, the effect of friction and surface texture on each other. So if you have a surface that's smooth like cardboard, you have, where'd my mouse go? Less friction, more speed. So here, look at this surface. So we have smooth cardboard surface, and if we push on our car, it goes faster than if we had something rough on our cardboard surface and we pushed it, it would go slower. So smooth, less friction, just like on ice, and more speed. But in this case, we're pushing it forward and it's going one direction and it's not sliding all over the place. Necessarily, if you used ice on there, you put ice on here, it might go all over the place. So if you have a rough surface, you have more friction and it goes slower. Okay, let's look at one more example. So applied force will change friction as well, and we talked about that. So if you just do what you did in the last slide, these are both cardboard, so they're both smooth surfaces. The surface texture is not being affected here. So you push the car on a smooth surface, you're just pushing it, and it goes fast. You push it here, and you put pressure or weight, add weight to your car, inside your car, it will go slower. Okay, so no force on the top of your car, less friction and more speed. And remember the ramps are the same. So you've what we call controlled for the surface. You have the same surface, and if you put force on it, it will go slower. Same situation, except that you put more force on the top and it goes slower. No force on the top and it goes fast. Same conditions otherwise. Okay, so let's get started, Daisy engineers. Step one, think about, design, and build your car. So what materials will you use? How will the pieces of your car fit together? Think about the size of the wheels, the axles, remember the sticks that the wheels fit onto and that go through that little hollow straw or tube. Think about the size of the wheels, the axles that will work best with the shape and size of your car, and even the weight. What will the body look like? Will you decorate it? Will it have windows or doors or steering wheel or a driver? You decide that because you're the engineer. Okay, so I gave the same list earlier, and these are the things that you're going to gather. So you're going to get ready to actually build your car. We have wheels here, we have the axles here. It looks like an axle's over here too, but I even used a really skinny paintbrush that I wasn't using anymore. So anything that's round and small enough to fit into whatever tube you're using, whether it's a little tiny tube that other than a straw, or you can use a drinking straw. Keep some rubber bands on hand because they will help stabilize your wheels to the axle if you need it. You may not need it. Glue guns, I love glue guns. So glue gun and glue stick. But you have to be careful because they do burn. And I don't know if you've used it, but I just burned myself yesterday. So if your parents prefer, then you should use something different than that. But that works. Fast glue, super glue works. Tape, masking tape or duct tape also works. So these are the examples of the 3 kinds of boxes that I was trying to decide about. This box is not really a box. It was half an egg carton that I flipped the lid upside down and I thought, and stuck it together. So I had a flat surface. Remember, that's the only really requirement is for this type of car, that the surface be flat. And these are boxes that my tea bags came in, and a matchbox, and some decals and paper and stuff that you might want to decorate your car with. Okay. Oh, and also the sloped surface and bath towel or some rough surface that you can put on the cardboard. So here we go. I'm actually going to build my car. So here's the tea box, and I didn't really want tea on the side of it, although that would have been fine. It could have been a truck that was advertising for Constant Comment tea, but I took another box and I painted it black because I kind of wanted it to look more like a car. And then I cut some axles, some little skewers, and I looked everywhere for wheels, and I ended up having to use these guys, which are the covers for votive lamps. That's all I had. Use what you have. And I've got 2 straws there. Next, you select the car body, then you make sure that the round sticks that you're using, the skewers that you're using, or the pencils that you're using, fit into the straws or the hollow tube and turn easily. Then you cut the straws a 1/2 inch wider than the car. So here's the straw, your drinking straw here. It's just a little bit longer than the width of the car. And then you insert your stick so that it is about a 1/2 inch, just a little bit longer than the hollow tube, but it's sitting in the tube. And then you attach with whatever you're going to use, super glue or glue gun, you attach the straw to the bottom of your car. okay? And once you do that, then you can add your wheels. But you want to add your wheels so that the stick goes all the way through them, but doesn't hit too hard against the straw, because you want to keep that axle or the stick with the wheel stuck on it. You want that to be really stable, and you don't want the hollow tube to interfere with that. You want it to move easily. So after you get the stick or the axle and insert it into the straw, both sides, front and back, then you cut a hole in the center of each of your wheels, push the stick all the way through your wheel, as long as it's not touching up directly to your hollow tube, and glue it. Glue all the wheels. So remember, you want to glue the wheels only to the stick part. I made my car, I made my ramp, and the first thing I tested was on the smooth surface, on the smooth cardboard. And it went kind of slow. Part of it is that the wheels aren't the best. So one of the things I wanted to change, if I could, was change the type of wheel, because they're kind of flimsy and they get bent easily. And then I decided I wanted to put these dynos in there to drive, and they were kind of fun to watch them as they wobbled and went down the ramp. They raced down the ramp. But it was still kind of slow, and I wanted my car to go faster. So then I thought about, what about force and friction? How could I make it go faster? I could take these guys out and I could make it lighter, right? Remember we talked about that. So you can make it lighter. There's less force pushing down, because these guys were weighting it down. And you know what? It went super fast. It was fun. It was fun. Although I liked having the dynos in there too. So, but you get to make that choice. Maybe you don't want it to go faster. Maybe you want it to carry dynos, and you don't care how fast it goes, as long as you can get the dynos down the hill. So I was playing around with all different kinds of cars, all different kinds of materials to make cars. I decided on the one that we've done today because it's a little easier for me to explain. But there's lots of videos. Look under do it yourself or make your own car. And there's so many ways to do this. So this is only a suggestion, what we've talked about today, but you don't have to do it that way. So a couple days ago, I took a pop bottle and I put the hollow tube or the axle housing through the pop bottle, and I taped it, and I put CDs. I had 4 CDs, and I call this Lori's Lamborghini. I put 4 CDs on here, and I ran it down the cardboard ramp. The first time, it fell off to the left side, and the left front wheel fell off. The next time I ran it, and I stuck it back on. The next time I ran it ran off to the right, and the right wheel fell off. I was frustrated. So, have you ever gotten frustrated like that? So I said, I wonder what'll happen if I run it without the front wheels. So I put it on the ramp, and it goes down the ramp, and it gets to the bottom of the ramp, and guess what it does? It flips over like this and keeps going. And so I did it 2 more times. Sure enough, it did the same thing. It goes running down the hill like this, and then it hits the bottom of the hill and it flips over like that and goes on. So sometimes things don't work out like you had hoped they worked out, but they can be just as fun or interesting anyway. So you're going to, step 2 is to test and observe what happens when you when you test your car on 2 different surfaces. So a plain surface and a rough surface. And then run 3 tests. So it's important to repeat whatever you've done, whatever your changes are. Make sure that it's what we call reproducible, or you can repeat it. So you run 3 tests on the plain cardboard and 3 tests on the rough surface. How did the type of surface change the motion of your car? We've already talked about this. If it's rough, friction is more, and what happens to the car? It goes slower, doesn't it? And did your car run the same way in all 3 tests that you ran on each of the surfaces? Sometimes they change. Sometimes mine fell off the side, at least on one trial. So step 3 is make changes, like I did with the dynos. I put them down and they slowed. I put them in the car to begin with, and then they slowed things down, so I took them out. So that was a change I made, and then tested it again 3 times. Did you get the same results every time? Maybe not. Did the change actually make the car go faster like you thought it would? Maybe, maybe not. Or maybe you'd have an interesting result like this guy. So step 3, change and retest. So something we call fair or controlled tests are when engineers test a change to their invention, they need to run what we call fair tests. These are also called controlled tests. And you do that by testing 1 change at a time. If you change too many things, you have no idea what caused your car to go faster or slower, or whatever change you wanted it to do. So you need to repeat tests in the same way, so you know the result from the change, the 1 change you made, is from that change and not from something else, some other factor. And then you need to test different cars on the same track to see if they behave the same way as the car that you made the change for, and the same car that you changed on different tracks, and see who goes faster, what surfaces made it go faster. So those are the kinds of fun things you get to explore as a scientist or engineer. And then one of the most important things is to make sure that you repeat the test, and it becomes a fair test if it meets a lot of these points that we made. And so repeating the same test several times. Reproducibility is what we call it. You can reproduce, you can repeat the same effect several times, and that helps for you to know that it was fair and a real change. So now that you've earned this badge, you can give service maybe by sharing what you've learned, how friction and force change the way objects move, how to design, build, and test a model car. So it'd be fun to teach maybe a cousin, one of your family members or friends how to do that, and talk to them about how engineers, what they think about when they design and build cars. And I wonder if there's some other things that you think would be fun to do as a Daisy engineer. I think one of the greatest things about doing experiments and building things is finding out how stuff works. And I hope that you had fun doing this. And thank you, Daisy engineers. Bye-bye.